Alright guys, welcome to Math 0314, section 4.3, multiplication of polynomials. The first part of this is just essentially amplifying what we've discussed. So when you multiply, we can multiply numbers together. We can multiply exponents together. I'm sorry, numbers with the same base together. And by multiplying numbers with the same base, what I mean is that we're going to add the exponents. So we can see that I just rearranged it. You don't have to rearrange it every single time. I'm just doing so just to be super clear. When we multiply numbers, we just multiply numbers. When we multiply numbers with the same base, we add the exponents. And the same thing here. With the y, don't forget there's a y to the 1. And that's it. So in the future problems, I'm just going to simply just multiply 3 times 5, get 15. I'm going to add the exponents here, get 5, and then add the exponents here and get 8. Moving right along. We have more of the same, so hopefully you should be able to do this. Pause the video, give it a shot on your own, and let's see what happens. So I'm going to assume you've done so. Negative 8 times negative 4 is going to give me positive 32. R to the third times R to the fourth is going to give me R to the seventh because we add the exponents. S times S to the fourth is going to give me S to the fifth. And I apologize, my S's and 5s look a lot alike. But there you have it. Alright, more of the same, just in a different manner. So if you see this, right, we're just going to apply distribution into all of these. So we'll do 5 times 2, which is 10. We'll multiply y cubed by y squared, which means we're going to add the exponents. 3 plus 2 is 5. We're going to apply that to the next side. So 5 times negative 7 is negative 35. Watch those signs. Y cubed times y to the first is going to be y to the fourth. And 5 times 6 is 30, y cubed. Because there's not a y there, we just write cubed. And there we have it. Alright, next up, a little bit uglier, but still the same process. Take this, multiply by this, take this again, and multiply by this. So go ahead, pause the video, give it a shot, try it on your own, see if your work compares to mine. So if I do this, negative 4 times 2, it's going to give me negative 8. A, remember this is a to the first, this is a to the third, so that's going to give me a to the fourth. I'm just adding. B to the 7b squared, 7 plus 2 is 9. C to the first, C to the fourth is C to the fifth. And apply to the other one. So same thing, negative 4 times negative 1/2 is plus 2. Half of 4 is 2. A to the third times a to the fifth is a to the eighth. 3 plus 5 is 8. B to the seventh times b to the first is b to the eighth. And don't forget, you still have the c, so we'll just tack on the c. And there you have it. So hopefully not too bad. Go ahead, pause the video, give this one a shot. These, by the way, are s's. So I'm going to assume that you've done that. More of the same. So half of 8 is 4. We have one s here. We have two s's here. So that's going to give me 3s. X to the third times just not another one. So I'm just going to say x to the third. On the other side, 8 divided by 4 is 2. Watch that sign. So it's negative 2. S to the 1 times s to the 1 is s squared. X cubed times x to the 1 is x to the fourth. Remember, we're just adding. 1 plus 1 is 2. 3 plus 1 is 4. Okay, so here's the famous problem that we need to make sure we're cool about. And the way to approach this is usually most students, when they see this, they think of something they've learned at some point in their academic career called FOIL, which stands for first, outer, inner, last. And FOIL is definitely a maneuver we can use to solve this. So and it's the most common way that people solve it. So we multiply these two together. So x times x is x squared. Then we do x times 5, which is 5x. So notice what I'm doing here. In green, I'm doing first, right? In orange, I'm doing outer. Then we're going to do, in gray, inner. And then in brown, last. So in gray, inner, and in brown, last. Okay, So once we've done that, all I need to do to finish this off is combine like terms. So x squared plus 8x plus 15 is the trinomial, is the answer. Okay. So foiling is the most common method. There are other methods. I'm not going to, most of the time, I'm not going to use these methods. I'm just going to use FOIL, but I think it's important to know other methods in the sense of understanding why this is true, right? And I never want you to assume that it's true because I said so. There needs to be a logical reason why. And let's talk about that. So first off, why does FOIL work? Well, what you're really doing is you're distributing x plus 3 into x and into 5. So this really means x times x plus 3 plus 5 times x plus 3. So now all I'm doing is I'm multiplying x by 3 times x, and I'm putting x plus 3 in the back, and x plus 3 times 5, and I'm putting the x plus 3 in the back. Okay? Now if I distribute again, so you can see foiling is kind of like a distribution of distribution, what ends up happening is we get x squared plus 3x plus 5x plus 15, and now when I put them together, we get the same thing, x squared plus 8x plus 15. So when we combine like terms, we get 8x squared plus 8x plus 15. And this is why it's true. Foiling just happens to be an easier way of approaching it, because what mathematicians realize on this step is that essentially what you're doing is you're multiplying everything by everything. And that, to be honest, is how I think of foiling. I don't actually think of foiling, I just think every term has to be multiplied by every term. Every term has to be multiplied by every term. Alright, there's a tertiary way of doing this, and the other way we can do this is something called the box method. So you make a tic-tac-toe grid, and ours is x plus 3, x plus 5, so we put x plus 3 and x plus 5. And so wherever our rows and columns meet, that's where we multiply. So what we'll end up multiplying is x by x, which will give me x squared. Then we'll do x by 3, which is 3x. Then 5 by x, which is 5x. And last 5 by 3, which is 15. So if we put this all together, we get x squared plus 3x plus 5x plus 15. And because the 3 and the 5x match up once more, we get x squared plus 8x plus 15. So 3 different ways, 3 different threes of the same results. So I think foiling is the easiest, so I'm going to tend to gravitate towards that. However, in the next one, number 7, notice that we are multiplying a binomial by a trinomial, as opposed to here where we have binomials and binomials. And my advice to you is whenever you see this, the tic-tac-toe method, the box method, tends to be a little bit easier to use. So I'm going to put the trinomial on top, 3x squared minus x plus 5. Pay very close attention to your signs. 2x squared plus 4 is going to go below, and we're just going to work through and multiply wherever they meet up. So 2 times 3 is 6, x squared is x to the 4th. 2x squared minus x is going to give me negative 2x cubed. 5 times 2x squared is 10x squared. Continuing on the bottom, it's 12x squared minus 4x plus 20. Watch the signs. And then once we're done with this, then we rewrite it. So we have 6x to the 4th minus 2x cubed plus 22x squared. Note that you have 10x squared here and you have 12x squared here. So together that's 22 minus 4x plus 20. And that is my final answer. So you can see the box method. You can use the other methods if you want, but I find that the box keeps it organized, and I would encourage you, if you're ever doing a 3x2, to use the box method. Alright, keep going. Here we have binomial by binomial, so I'll go ahead and just FOIL like regular. So 3 times 7 is 21, y times y is y squared. x1, 3y times negative 6 is negative 18y. Then we have 2 times 7y, which is 14y. And then we finish up with 2 times negative 6, which is negative 12. Once more, we look at it and we see we have like terms here, so we'll put them together. It's negative 4y. Watch those sides, and everything else lines up. Number 9, we'll do the same sort of thing. We'll multiply everything by everything. We'll FOIL, so we get x squared. Negative 7 times x is negative 7x. 7 times x is 7x. And 7 times negative 7 is negative 49. Now what's interesting to note here is in the middle they cancel out. So this leaves me with x squared minus 49. And this is one of the most important rules that you'll see in math, which is called the difference of squares. And the difference of squares essentially is that as long, what was the original problem? X plus 7, x minus 7. If everything matches up except the signs, then all you have to do is square, and it doesn't matter whether you're looking at the first or the second, it doesn't matter if you're looking at the positive or the negative version of it. Square both and put a minus sign in the between. Because what we're always going to have in the middle is that they're going to match up but be of different signs, so they'll cancel out. So if we look at this question here, it appears to be a problem that we can just FOIL, and you can, but it is also the difference of squares because the first two match up and the back two match up. So if that's the case, just square the front. So notice 6 squared is 36, c squared is c squared. Square the back, 49d squared. Put a minus sign between them, and you're done. That is the beauty of the difference of squares. Very, very useful. Makes your life real easy. Very common in all tests. Any sort of standardized test you take, you will see the difference of squares. More of the same here. So 5x squared is 25x squared. 4y squared is 16y squared. Put a minus sign between them. Note the order does not matter which one comes first. When you multiply, order doesn't matter. It's called the commutative property. Right along. The next one here is 5x minus 2 quantity squared. And the common thing that students like to do is say that, well, this is just 25x squared minus 4. Just distribute this into both. But that is not true. And an easy way to show you why that's not true, multiply any two numbers. All you're going to use 5 minus 2 squared. And we know that 5 minus 2 is 3, and 3 squared is 9. But if I do 5 squared minus 2 squared, I get 25 minus 4, which is 21. Which shows you that these are not the same. Okay? And that is very, very, very important, so realize that that is not true. Okay? You will have most students have a natural tendency, at least initially, to want to do that. What this does mean is that when you square something, you multiply it by itself. So what we really have created is a foiling situation. So 5x times 5x is 25x squared. 5x times negative 2 is negative 10x. Negative 2 times 5x is negative 10x. And negative 2 times negative 2. Oh, don't want to do that color. Negative 2 times negative 2 is positive 4. So what will happen, and what will always happen is in the middle here, you actually end up doubling, right? And that makes sense because if I take a plus, it doesn't really matter if it's a plus or minus b, and you multiply by itself, you're always going to end up getting two ABs in the middle, right? You're going to get AB here and AB here. So because they match up, it'll become a squared plus 2ab plus b squared. And if you realize that a plus b quantity squared is equal to this, if you have this in your head, if you remember this, then questions like this become very easy because all I have to really do here is square this, watch the sign, but negative times negative is a positive, and then I just multiply these two together, times 2. So 5 times 2 is 5 times negative 2 is negative 10 times another 2 is negative 20. Put 20x. And notice that this is the same thing as this. Okay? So you can always use that as a method. If you're not comfortable with it, it's just a little bit of a time saver. What I'll say is that if you're planning on progressing and doing a lot more math, it is in your best interest to always to learn this, because you don't want to get caught up in easy math. This will eventually become easy math, and you don't want to get caught up in doing stuff like this, because problems will end up taking a lot of time. So you want to be able to zip through situations like this. But moving right along, I wanted to go ahead and try to use what I just mentioned. So what I said is that you square, essentially we square both of the terms, and in the middle it's 2 times the product of the two. So we'll square both of them, and the middle will be this times 2. So c times negative 3 is negative 3c, times 2 is negative 6c. Alright, more of the same. Looks a little bit harder, but really it's more of the same. So I said we square this, so that's 16 x to the 6. Notice that if you square 4x cubed squared, 4 squared is 16. X to the third raised to the second power means that we multiply, so we'll get 6. That's where that's coming from. The back one is going to be plus 9y to the fourth. The middle will be these multiplied together times 2. So 4 times 3 is 12, times 2 is 24, and then we have x cubed y squared. And so you can see that if you have this in your head, it makes these problems go by real fast. Alright, so now we are into the complicated section. So pause the video, try this. It shouldn't take you that long to actually do. It's complicated, but it's not that bad. So I'm hoping that you took a shot at it, and I'm hoping that you realize that because this and this match, and this match, we have the difference of squares. So this is x squared minus y plus z squared. Now this guy right here is what we just finished talking about. We can just square the first one, square the back one, multiply these together times 2. So that would just be 2yz minus x squared. And that is the answer. Notice that nothing is alike, so we can't combine any like terms. So there's our answer. So you can see, hard problems are not even that hard once you realize what the rules are. So I hope that's okay. If you feel like this is going too fast, just rewatch the video and you'll see that it's actually really not too bad. Alright. Last one we want to talk about is x plus y cubed. And what I want you to realize here is that this is x plus y times x plus y times x plus y. And so there's no special, well, actually there is, but in this course what your textbook is going to stress for you to do is just to clean it up, and then whatever the result is, multiply the result by x plus y again. So this part here should be easy. It's just x squared plus 2xy plus y squared, based off the rule we discussed. And this quantity, note it is a quantity, is going to be multiplied by another x plus y. So, just like we said earlier, when we multiply a trinomial by a binomial, we want to do exactly what we did here. We want to make it into a grid because it helps to see what's going to happen. So we're going to get x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. We look at all that and nothing is matching up, so we're just going to rewrite it as such. And there's your answer. One last, well, yeah, let me go ahead and show you. There's another way to do this, and this is not in the course, but I want to just expose you to it. There is a mathematical idea, I guess is the way I'll describe it, called Pascal's triangle. And the cool thing about Pascal's triangle has a bunch of properties. But one of the properties that Pascal's triangle tells you is what the coefficients of any values are according to what row you're using. So, sorry, I made a mistake here. This would be 0. This would be 1. And this would be 2. So what I'm saying here is that notice that we have a 1 here and a 1 here. So these are 1, this is 1. Notice that when I expand x plus y squared, I get x squared plus 2xy plus y squared. This is the property we've been talking about today, which is 1, 2, 1. So this is 1, 2, 1. So what ends up happening is that if I'm doing x plus y cubed, what I can do, I know that the coefficients will be 1, 3, 3, 1. The first term is x. The second term is y. And what you'll notice, and this is a phenomenon that will always occur, is that as one decreases, so notice that x squared goes from 2 to 1 to not even being there, the other one increases. So notice you don't have a y, but now you have y1, and now you have y squared. So notice here, when we wrote the final answer, we had 3, then 2, then 1. Oh, you know what? I apologize. We do have like terms. I didn't even see that. We can put this and this together. So this becomes x cubed plus 3x squared y. And this one, x y squared plus 2xy squared becomes 3xy squared plus y cubed. Apologize about that. In any case, you'll see that they're descending. So 3, 2, 1, and then you don't have an x, and then here you don't have a y, but now you have 1, then you have 2, and then you have 3. And so if that's the case, then what we have going down is this goes 3, 2, 1, 0, and this is 0, 1, 2, 3. Also note the symmetry that is existing between these. So I don't actually even have to go in that order. If I wanted to go 0, 1, 2, 3, and 3, 2, 1, that would work as well. So in any case, this gives you what the answer is. Okay. So this is another way. This is called the binomial expansion. So it's a nice little method. Pascal's triangle, by the way, if you're curious how I was getting these values, you just add these together. So 1 plus 1 is 2. Here 1 plus 2 is 3. 2 plus 1 is 3, and so on and so forth. And you have 1s on the outside. So, nice little theorem. You probably won't use it too much in this course, but if you do progress in math, I would encourage you to have this in your head. It does help you out in future math courses. So, that is it, guys. That's the last problem. Thanks for listening, and I'll see you guys in the next video.